during one season, and then when the uptake is stopped, then the concentration is increasing. So he was able to see the seasonal variations. And then at the end of his research project, he wanted to continue, but he didn't receive the funding for that. The National Science Foundation said, well, it doesn't seem so interesting what you're doing. And the very important thing about Charles Killing is that he decided to continue. He decided to continue thinking that it was interesting to confirm the first result in the long term. So he continued. He found some personal funding from the university. He managed to continue in a way or another, continue doing the monitoring of CO2. And then he realized that not only there were seasonal variations, but also that the concentration was changing. The concentration was increasing. And in 1963, after then 5 years of monitoring, he was showing his results, and his results were used by the people in charge of climate science to show that there was a clear increase in CO2 in the world, at least at this place, and that may have some very strong implication about the climate. So the story of monitoring the atmospheric composition started with the story of Charles Killing. And it is interesting that now we have a very nice curve, which is called the Killing's curve, which is showing the increase in CO2 concentration at Mauna Loa since 1958. This is the longest record that we have of CO2 in atmosphere, and it shows something that is now well known to everyone, which is the increase in CO2 concentration since 1958. And the increase is very strong. There is more than 200 ppm more CO2 in the atmosphere as respect to 1958. And this is only at the beginning because someone understood the importance of doing long-term measurements. If you do measurements 1 day, 2 days, that's interesting, but it never will replace the long-term information and this curve. So obviously, the fact that we had one single place was to do the measurements was not enough. In fact, Charles Killing started also doing, at the same time as the monitoring at Mauna Loa, he was doing some monitoring in Antarctica. And then, based on these results and on the fact that the concentration was increasing, other people, other institutions started all over the world to do these kind of measurements. And now these measurements are extremely important. They have been extremely important because they form the basis of climate science. The increase in CO2, which is mainly due to the rich countries in the world, the increase in CO2 is clearly the main responsible factor for climate change. Climate change is something that we already see now. It's not tomorrow, it is now. And it is CO2 emissions that are responsible for that. These curves and the data from monitoring CO2 are used everywhere by all the climate scientists to understand how the climate will look like 50 years from now, 30 years from now. They are used to understand whether the countries in the different area of the world are indeed limiting their emission, because it is easy to say when we have the actual facts, the measurements in the atmosphere, whether there is progress in limiting the emissions. And if the political, the climate policies to limit the emissions are effective in the different countries. So this network of stations measuring CO2 has been extended to different places in the world, because it is just like if you do the monitoring of the weather with only one station, it will never give you a valuable information. You need plenty of those. And this is why we started in Chakaltaya this monitoring of CO2 back in 2014. We have at the top of Chakaltaya, 5,300 meters high, a very unique station that is monitoring CO2 the same way as CO2 is monitored at Mauna Loa, with the same techniques that can be compared. So we can directly compare the record at Chakaltaya and the record at Mauna Loa. And this was something extremely important, and we are providing this data to different places in the world, to different scientists that are using and monitoring the climate and using this data to make climate forecasting. Obviously, the CO2 is not the only gas or particles that is present in the atmosphere. There is plenty of other compounds that are acting on climate. So the greenhouse gases like CO2, but also methane and N2O, they are very strong in warming climates. This is the greenhouse effect. They are warming climates. But there are other compounds in the atmosphere that have the opposite effect. And in particular, the particle, las partículas, y the clouds, las nubes, have the tendency to make the atmosphere colder. So it is opposite effect to climate, to greenhouse gases. It's even more complex with the particles, because in the particles, there is different kind of particles. El carbonio negro, the black carbon, is actually emitted from combustion, and it's black, and it absorbs heat, and it increases, actually, it warms the climate. El sulfato, sulfate, which is emitted by industries or by volcanoes, it's actually a white particle, and it reflects the light, and it makes the climate colder. And so for particles, it's a bit more complex than for the greenhouse gases, because we need to understand which kind of particles are present at which altitude to make a forecast of climate change. And we know that the main factor is CO2 increase, but we also know that the main uncertainty on future climate is how will be the role of atmospheric particles and clouds. Atmospheric particles and clouds are also pollutants in the urban areas. In La Paz, El Alto, you're breathing every day a lot of particulates which are harmful to your health. And so we have to decrease the emissions. And this is why we need to monitor all these compounds to understand the future of atmosphere and the link between air quality and climate. And this is what we do in Chakaltaya. In Chakaltaya, since 2010, we are monitoring greenhouse gases, particles, reactive gases. It is a station, la estación la más alta del mundo para el monitoreo de la composición atmosférica. It is operated by the experts of LFA, Laboratorio de Física de la Atmósfera, a vuestra universidad. Muy importante porque es el único lugar, son tres lugares en Latinoamérica donde se hacen estos medidos de la composición atmosférica. Uno en Chile, el otro en Brasil, y la más alta en Bolivia. What we do is we try to understand these to respond to these questions. For example, with the station in Chacaltaya, we know how the biomass burning in the Amazon is changing the composition, the atmospheric composition in the Andes. We know how the pollutants emitted in La Paz or El Alto are actually exported to other places in Bolivia, but also elsewhere. We understand if the policies that are put in place in Bolivia, like for improving the air quality, are actually effective. And people will use this data to understand what will be the future climate in Bolivia and in the regional Andes. So the work that LFA is doing and that we are doing with a team of international scientists with the people there is, I believe, extremely important and unique. And I understand that a lot of students and young people are actually listening to this talk, and I would like to say something about predicting future climate in Bolivia, because you have a very expert team at the UMSA, which is recognized by many people in the world as one of the unique teams in Latin America that can form people, students, to the techniques and what you need for predicting climate change. And it is extremely important that LFA is actually preparing the young scientists to engage in climate science. It is important to understand that climate science and the air quality that you have in La Paz are the same thing, more or less. And that when you're working to improve air quality, you're also improving climate and vice versa. So this is really important also for your health. It is important for the young people to understand that you need plenty of different expertise to tackle climate change. You need the people that know about physics, like the one who are prepared by LFA, but also chemists, also biologists, and also people who do not have necessarily a scientific background. They can health, people working with health, people working in social science are also extremely important, and they will be needed in the future, together with people working with the city planners. They will be needed to make sure that Bolivia is organizing its own response to climate change and its own mitigation to the future of the environment. And so my message is, again, to finish my talk, to encourage the young people listening to this presentation to engage with their skills into climate science and into finding the solutions that are most suited to your own countries, because no one else besides you will be able to do that better than you. Entonces, he terminado. Quisiera regraciar de nuevo a Marcos y a todos los amigos de la LFA para la organización de esta presentación, de este evento, y también para todo el trabajo que estamos haciendo juntos. Y me falta Bolivia, no he podido venir este año, pero 2021 sería, son seguro, un año mucho mejor para todo y para Bolivia en particular. Muchas gracias.
Muchas gracias, Paolo. Muy interesante, y muchas gracias también por las palabras para el laboratorio y para la UMSA. Para nosotros es un placer también trabajar contigo y con tus colegas. Tengo una pregunta. I think I will switch to English as well for the question, just to be sure that it's clear. The person is asking, we are in the highlands, how this is related or to the increase of CO2, to the concentration of the CO2 here. Is this different? Maybe the question was, is this different from what is seen in Mauna Loa or in other parts of the world?
Yes, it's a very good question. I think what is important, I have difficulties to switch from English to Spanish. I want to speak Spanish, but lo que es importante es que la CO2 es un gas con un tiempo de vida muy largo, 100 años. Entonces, cuando se emite una molécula de CO2, mediamente se queda 100 años en la atmósfera. Entonces, puede viajar lejos. Y es verdad que hacemos una medida en Chacaltaya, en los Andes, pero es una información global, porque no es que estamos haciendo una mesura, una medida de la CO2 que está emitida de Bolivia. Es una información global. Cuando se hace la comparación entre las medidas de Mauna Loa y Chacaltaya, tenemos más o menos la misma concentración. Es la concentración de la atmósfera global. Hay diferencias en la variación estacional de la concentración, pero las concentraciones están más o menos las mismas y están increasing con la misma rate.
La misma tasa, sí.
La misma tasa.
Muchas gracias, Paolo. Realmente, insisto, muy buena la charla y por favor quédate con nosotros por si aparece alguna pregunta más al final. Gracias,
Sí.
Paolo.